That's how Beta's flying several hundred miles when the equivalent airplane goes twice as far. Even though batteries are 30 times less energy dense, by the time you take a systems level approach, you say, okay, that's a meaningful range. And then the big kicker is you're doing it at a 40th of the cost of energy. A 40th of the cost of energy.
Welcome to Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. I'm your host, Shashank Nigam, the CEO of Simply Flying. On this show, I speak with aviation leaders, innovators, and policymakers driving real action, separating the signal from the noise to spotlight what's truly moving the industry forward. The same focus that is at the heart of our new book, Sustainability in the Air, Volume 2. In it, Dirk Singer and I take stock of how far the industry has come and how far we still need to go. With the global carbon budget potentially running out by 2032, the clock is ticking. But the most promising solutions today aren't just environmentally sound, they are economically superior as well. From SAF and contrail mitigation to direct air capture, the book offers a practical roadmap for aviation's journey to net zero. Get your copy today. Link in the show notes. My guest today is Kyle Clark, founder and CEO of Beta Technologies, one of the most advanced electric aviation companies in the world. What began as a college thesis on efficient aircraft design has evolved into a vertically integrated aerospace company building all electric aircraft today. It is now backed by major strategic players, including Amazon, which recently disclosed a roughly 5.3% stake in Beta. In this conversation, Kyle shares Beta's unconventional path to scale, why electric flight is already viable for real-world missions like medical and cargo operations, and how systems-level design is reshaping the economics and credibility of electric aviation. Kyle, it's a pleasure to be finally speaking. Beta is no longer a small upstart company from Vermont. You have just IPO'd. How does it feel to begin with?
Well, it still feels like the same company. It is, small is all relative. Aerospace has some pretty big companies, and there's not a face that I don't recognize within the company. We are, highly vertically integrated in a relatively small campus here in Vermont. It doesn't feel that different. However, the expectations are significantly larger, and the energy is high, and people are recognizing that we have to do a lot with the technology that we've developed. So there's a lot of pressure to answer your question. There's a lot of expectation, but it's married with a lot of fun and excitement.
Well, congratulations on being one of the few new future aircraft companies to have actually IPO'd and come this far. It means a lot, I think, to the entire industry, and we're all rooting for you. In preparing for this interview, I came across a very, very interesting origin story around Beta, and I would love to hear directly from the horse's mouth. What got you to do this?
I assume I'm the horse, and I will. The founding story of Beta. So Beta was actually by name my senior thesis in college quite a while ago, and I really focused on this concept of simple aircraft design, aerodynamic efficiency, propulsive efficiency, and designed this around kind of a two-seat inline airplane that at the time was proposed to be hybrid. That actually won the thesis of the year at Harvard University way back in 2004, and I couldn't get anyone to invest in it. I pitched to everybody to the point that, like, at the Thanksgiving table, my mother's like, "Will you shut up about the airplane thing?" But I just loved it, and I was really obsessed with it. But I couldn't get anybody to invest in it after college, so I started some other businesses, mostly focused on technical products, so power electronics, high reliability motors, did the design behind the Patriot missile system electrification program, a lot of Tesla's commercial and industrial power supplies, large wind farms, and I learned how to design really, really reliable power electronics and electromagnetic machines. And finally, in 2017, I was talking in Philadelphia about beta and electrification. And Martine Rothblatt, who was the founder of SiriusXM Radio, she grabbed me and she goes, "We need to talk." And that talk, by the end of the week, I met her, spent, I don't know, 12, 14 hours with her straight. And she said, "Write this down and tell me how you want to do this." And I sent her a hand drawn watercolor type thing and said, "This is what I think we should do." And her response was, "You're on. That's it." And, and we did it. And so we kicked off the business, kind of together with her as our first customer. At that point, she wasn't an investor in the business. She was just a customer. And we signed a contract that had a singular objective. It said elicit critical thinking in electric aviation. That was the contract. And she funded the development of a 4,000-pound electric vertical takeoff and landing aircraft that we built in 10 months with 8 people. And it was just a boatload of fun. And we proved that electric flight worked at a reasonable scale. And I flew about 100 test flights in the airplane. And that catalyzed us to our next phase, which was developing commercial aircraft.
I have to jump in here. Were you not doing a job at that time? Did you leave that job, come do this full time? You had 8 people. You skipped a few parts there.
Yeah, no, that's a great question. I had started a number of companies, but one of the companies was a bank called Venture Co. And so I had got my investment banking license and wrote some software and was working on that. Now, because I was the fiduciary for that bank, because I hold the Series 7, 63, 24, and a 79 investment banking license, I had to stick around with the bank for a year and still like review all of the deals as I transitioned out. And finally, we found somebody to kind of cover that portion of it. But it's a great question. None of this stuff, like, nobody's just sitting around waiting for something to happen. Like, I was working really hard at the time, and but it wasn't in the field that I was passionate about. It was something that I was actually, the very first project on the bank was Beta Air, which is fun. So I started a bank to try and raise money for a company that I wanted to pursue. But yeah, it's never as clean as kind of the retrospective view it is. There was a lot of like, how are you going to juggle all these things? There's no money, and the house is on its third mortgage, and you're like, I think this is going to come through. And then, you have you pull out everything that you possibly can to start a business. And in retrospect, everybody's like, oh, well, it must have been easy. It just worked out. People were throwing money at you. It's not the case. When United Therapeutics funded us, most of the people here, because we wanted to put all of that money into hardware and development, we're just working without pay. Like that was the de facto kind of, position for most everybody that was on that team.
Wow. Fast forward to just a few months ago, I had my first beta experience where I was invited by a team in Toronto to see the first electric flight in Canada, which was a lot of fun. And I took a selfie in front of the aircraft with the CN tower behind me, and it was my WhatsApp status picture. So a lot of my friends in aviation replied to me saying, "Listen, this is a very interesting model. Which air show are you at? This thing doesn't fly, right?" I said, "No, here's a video of it flying." And most of them couldn't believe it. The first thing was, "This doesn't fly. This is just a demo." They probably drove it up in a truck, but actually spoke to the pilot who had flown it up from Vermont itself. I believe you have flown test flights yourself in the aircraft.
I have flown many, many test flights and first flights, and I don't know if it's still true, but about a year ago, I was informed that I had the most time in electric airplanes of anyone in the world.
You should get a Guinness Book of World Records for that.
It's probably been surpassed because we have a lot of people flying a lot now, and we have a small fleet of electric trainers. We have multiple of these things around the world. So, but look, we get that reaction all the time. I remember with Pete Buttigieg, who was the Secretary of Education at the time, we flew the thing into Louisville and we parked it underneath the wing of a 747. And it was in the hangar, and he came and I introduced myself and I said, "It's an electric airplane." He goes, "All electric?" I'm like, "Yeah." And he looks at me in this kind of weird look and he says, "How did you get it here?" And I'm like, we flew it here from Vermont. And this was like 5 years ago, and his eyes lit up. But I get that reaction, like we'll fly into these small airports and there'll be some corporate flight taking off and the pilots will be like, what is that thing? And it's a proud moment, but a funny moment always when you say this is an all electric airplane that just flew from California to Wichita or whatever, people just have a hard time believing that's the case because they don't want to believe that batteries have an energy density and propulsion has a propulsive efficiency to make this beautiful thing fly today. But when they get in it and fly it, they realize that, holy cow, not only is it real, but it has real tangible advantages over traditional aviation.
Right, right, right. And let's look at the category itself, right? eVTOLs or UAVs, especially since the Uber Air white paper days, it's littered with a lot of companies that were very ambitious, tried to do a lot of things and didn't make it. You have focused on the Alia eVTOL and the CTOL at the same time. And if somebody went through your IPO filing details, there's an entire ecosystem you're focusing on: the batteries, the chargers, all of this. What's the overarching objective here? Why do so many things rather than just one thing?
Yeah, it's a great, great question. So let me just describe like what it is that we're building, right? The obvious thing that we're building is a 7,000-pound aircraft that carries 6 people that flies several hundred miles. Now it comes in 2 forms. Either it flies airport to airport and it doesn't take off and land vertically, or you add the lift rotors and it takes off and lands vertically. It's like float plane floats, right? You get some flexibility, you increase the drag, increase the weight. That's effectively the same thing here with the lift, but you have the ability to take off and land vertically. Now, you asked the question, why do so many pieces of this? And I'll tell you that aerospace engineering is a technologically unforgiving pursuit. You have to be optimized on almost every front. You can't be really good at making engines and propellers and forget about the structural weight fraction. You can't be really good at aerodynamics and forget about the propulsive efficiency because they all play together to create performance in the aircraft. You have to have a slippery airplane, one that's lightweight, that carries a lot of energy and transfers that precious energy into propulsion efficiently. You have to do all those things at the same time. Now, every system on the plane has to be very utilitarian. You don't get to put extra things on the plane. When you design automobiles, a car that looks fast isn't necessarily fast. You do it for aesthetic reasons, right? You do it for floor presence and showroom presence. In airplanes, there's no sense of humor for that. You have the shape of the wing, the shape of the nose, the placement of the windows, the shape of the landing gear. All of those things are very utilitarian. Now, they happen to look beautiful because airflow likes to go around shapes that have, not a lot of discontinuities or second derivative curves. There's a lot of like thoughtfulness in what our body perceives as physically optimized in aircraft. So when you do that, back to your question, why design all these things? It's because the motor has to be in harmony with the propeller, has to be in harmony with the batteries. Well, what is the motor? The motor includes the inverter. The inverter has to be accommodating a wide range of voltage because batteries start at one voltage and at another voltage. So you design an inverter in a certain way. Now, the inverter then, of course, the capacitance in the inverter has to be tuned with the inductance of the motor. So now you're going to have all these multidisciplinary things that come together. If I were to go out, and let's examine the counterfactual for a second and say, well, don't do all the things yourself. That means at the beginning of the development project, you have to define the requirements and in many cases, the interface control documents between what you're creating and what you're asking a supplier to give you. That's pretending to know more than you know at the time that you're giving the information. If you do that, you're going to be suboptimal. So back to the whole thesis. This is a technologically unforgiving pursuit. It has to be system level optimized. In order to do that, you have to defer the creation of ICDs to the point that you've maximized the mechatronic design functions of the plane and you've minimized the parts, brought the weight down to a minimization, the reliability up, the efficiency to its maximum state. and then you lock those things in. And you don't get to do that if you don't do it yourself. Or at least it would be really high friction to do that.
I hear you on vertical integration, and we've seen successes in non-aviation industries like Tesla, vertically integrated, trying to do everything themselves. But how do you ensure you don't lose focus of the end goal, and more importantly, don't run out of money in trying to do so many things? Were there certain proof points you had to keep hitting to ensure success?
Yeah. Well, look, we might run out of money. We might fail. That's a very real possibility. It's a more of a possibility than we don't. But the outcome of the risks that we take and the benefit to society and the benefit to the world is so great that the risks have to be commensurate with that outcome. So we are not playing the game of trying not to fail. If we do, we should not even start this, right? Because the probability is that we are. However, we are doing everything within our power to not fail. And yes, it increases our spend, our people, and it reduces our focus on any one part if we try to focus on multiple parts. Now, this is kind of the nature of the developmental philosophy here is we make everybody aware in the company of the end goal, and then we focus on how they're going to support that goal. And 3 times a week, the whole company gets together and every team identifies what they're doing that day to support the end goal of that quarter or that year. You apply that philosophy to the technological construction of the airplane as well. And you don't lose focus. You say, this is your contribution to focusing that laser beam down the way. And it does cost money. It takes somebody who thinks in systems, somebody who's able to be, multidisciplinary. We have, I would say, one of the best CTOs in the world. His name's Dave Churchill. He's a polymath. He's able to think about this stuff in a diverse way. And we have a team that work with him that are similar in thinking. So our technical team here is able to kind of grasp all that. But I want to hit the very key punchline here, and you hit it early, which is, yes, there's a lot of things, but the simplification of the entire aircraft is what makes this possible, right? We still have a very, very simple aircraft. Now, we do all the things in the aircraft, but it's a simple aircraft. And that allows us to get this optimization thesis right.
I love it. I love it. And I appreciate you diving into some of these technical details, right? Because electric aviation, just like electric cars, have certain misconception. Oh, what about battery range? What about load? What would be one common misconception people may have about electric aviation performance?
Yeah. It's a great question. People often come to me and say, hey, electric airplanes don't fly because batteries are too heavy. I'm like, too heavy with respect to what? Like, go pick up that Lycoming gas engine. It's 550 pounds. Now we can go pick up our electric motor. It's 100 and change. So you've 5 times reduced the weight of the motor. And you're like, well, now let's talk about how much batteries weigh. Well, how much do they weigh per energy content? That's one part of the variable. But the more important one is now you've got X amount of energy, kilowatt hours in a battery or joules. We then are going to convert that into propulsion. When you convert gasoline or diesel fuel into propulsion, you do it on a very good day at like 30% efficiency. When you do it with batteries, you do it at like 95% efficiency. And you're like, oh, well, you have a 3 times benefit in converting that precious energy into propulsion over the fuel. Now, the fuel has a higher energy density, and it's about a 30 times higher energy density than batteries. So now you're only a 10-to-1 difference. And then you multiply that by the drag of the airplane. And you say, oh, but if you're going to convert that fuel very inefficiently to propulsion, that inefficiency is called heat. And you have to get rid of all that heat. So now I'm going to put a bunch of radiators and open fans and other things that increases my drag by 30 to 40% just to cool off the things that converted that gasoline or that diesel into propulsion. So now you reduce the drag by 30 or 40%. And you're like, okay, if I reduce the drag by 30%, I get to reduce the propulsion I need because I don't have to push the drag. And when you compound all that together, you end up with a lift-over drag ratio and a propulsive efficiency that's about twice as good on the leftover drag ratio and 3 times as good on the efficiency. And you're like, okay, I've recovered half the difference between what I have in my gasoline to what I have in my batteries. And all of a sudden you say, oh, that's how Beta's flying several hundred miles when the equivalent airplane goes twice as far. Even though batteries are 30 times less energy dense, by the time you take a systems level approach, you say, okay, that's a meaningful range. And then the big kicker is you're doing it at a 40th of the cost of energy, a 40th of the cost of energy. So you might go half as far. So then the real question is, what missions can you attain by going half as far? Well, or a third as far, or even 10th as far. Well, it's a ton of missions that you can do. And you do it at a fraction of the cost, and bang, you've got a business. So there's naysayers everywhere. And like people are constantly opining on LinkedIn about how stupid and how people were wasting their money. And my only response to them is come and fly with me. Just come and get in the airplane. Shut up on LinkedIn and come and get in the airplane.
Come fly with me. Sounds like a song I like. Recently, I was at the Dubai Air Show. I met Simon Newitt, and I was there for the announcement. And what I found very interesting there was the usage of the aircraft was not for traditional passenger traffic, as you would imagine, but for high value medical equipment, for cargo. Now, how do you get to develop these use cases, and how do you prioritize cargo versus what type of cargo, people versus what type of missions for the people? Do you go from Manhattan heliport to a JFK and catch the Delta first class passengers? Do you look at medical cargo? How do you design for these use cases?
Yeah. So the design for the use cases, like all of those use cases, want a safe, reliable aircraft that gets from A to B with meaningful economy. That's like there are nuances in the design, but the baseline of the wing and the tail and the control system and the propulsion is going to be equivalent no matter what use case you do. Now, the next question is, what use cases can we do now? What use cases are a low barrier to entry? Well, flying in and out of Manhattan or Chicago or Dallas from the suburbs requires municipal approvals. It requires airspace changes. It requires new helipads, pads, and vertiports to be put in. When we already have hospitals that have helipads that are looking for organs or medical equipment or personnel, we already have military bases that are ready to accept this technology. That becomes a much more logical early entry point. And then cargo and logistics takes away the variability of convincing thousands of people to get on the airplane, because you convince one person, the loadmaster or the CEO of the cargo company. You say, look, it costs less, it's more reliable. And they're like, okay, I'll take that. And then you start flying cargo. My point is that we are not doing passenger, but we're doing it in sequence. We're doing military, medical early, we're doing cargo and logistics, and then we're doing passenger. We're doing it both horizontal takeoff and landing and vertical takeoff and landing. And we've taken a lot of spears for that as well. Where people say, well, geez, your optimization point for vertical takeoff and landing must be different than airport to airport. But when you really break down the flight profile of vertical takeoff and landing, you're spending upwards of 95% of your time as an airplane, right? So you're really going to optimize for the airplane part of this anyway. Now, do you have to make a stiffer and a modal, you have to make a structure that recognizes the modes and the vibrations and the loads associated with vertical takeoff and landing? For sure you do. And there's another misnomer. People think the loads of vertical takeoff and landing, in an ultimate sense, are going to be greater or equal to those of aerodynamic loads imposed on the airplane while it's flying. That is not true. You can actually produce much greater loads in almost all enveloping cases by flying really fast and ranking on the controls versus pushing air down with a fan. It's just the physics of it, because V squared makes the force aerodynamically. So you once you understand these things, you start to understand why. In the first part of that, sorry for talking so much. I know that's a point of a podcast.
No, this is very interesting, at least to me, and I'm sure to a lot of the listeners.
So in the first part of it, it's like why is your market entry strategy through medical, cargo, logistics, then going into passenger? Well, because the friction is lower, the customers have a use case that we can do today, and they're willing to pay for it, and they recognize the low cost of the aircraft and the value associated with it. Bang, easy. Why are you doing CTOL and VTOL? Well, the certification path's easier. The physics all support it.
Mm-hmm.
Get type certifications in a stepwise way. Start bringing revenue in earlier than our competitors, and it doesn't require any changes to our airspace. and all of a sudden we've got a product in the air. It's actually, like, I think, a way more thoughtful, and it's working. Like, I'm looking at a production line making these things that are going to go out there and fly in the eVTOL integration pilot program early as advanced air mobility aircraft and then migrate into VTOL aircraft. All the pieces have fallen into place, probably because of dumb luck, because I know I'm not that smart.
Well, I recall this is very, very interesting in terms of use cases and applications. I recall that aircraft I saw in Toronto was a few weeks away from getting shipped to New Zealand for Air New Zealand. I believe that's being tested in New Zealand right now between South Island and North Island. You've also got partnerships and orders with the likes of United Therapeutics, UPS, Bristow, and others. Are you able to walk us through? I love the customer led approach here, but the differences are huge. Which one do you prioritize? Is it just about, who can bring in the revenue first? We'll prove that use case and then go from there. Or are there any other considerations you have here?
Yeah, it's a very good question. Well, so the actual design of the airplane is identical in all of these cases, right? There's 200 cubic feet of cargo space. There's 2 pilot seats. Only one is required for flight. The other one is optional for training. Every one of those customers wants that. They said, we want a lot of volume. We want the ability to train people. We want an airplane that goes from A to B. Now, the key is selecting the launch cases where the range is relatively short for airplanes, because that's where you exploit the biggest value. You don't want intermediate charging stops during a mission. So in the case of New Zealand, it's an awesome, awesome application because everything within that island is basically within striking distance of our airplane. Certainly, if you start at the middle and go out. Up in the Nordics, we have another airplane up in Norway doing the same thing. The geographic impediments to traveling up there are pretty large. Big bodies of water, fjords, other things. The airplane covers a lot more ground relative to the ground transportation. Up in Seattle in the San Juan Islands, we stopped there on the way out. We did a bunch of flying there, like to show how you can take a 10-hour truck ride and reduce it to a 40-minute flight. And that's with ferries and all the bridges and everything in between, right? So these applications, although they like maybe carrying medical stuff or UPS cargo or any of these things or New Zealand's cargo, they're really doing the same thing. It's selecting the characteristics that really matter and exploit the benefits while respecting the detriments. It's not the perfect tool for everything. Motorcycles suck on days like this in Vermont, right? I love motorcycles, but you don't ride a motorcycle when we get 10 inches of snow in the mountains, right? So my point is that you have a horse for a course, or you have a different use case. We go and select those use cases based on the important parameters, as opposed to whether or not like it has a title on it.
I love it. I love the approach. Now, we've come so far. You've got your pilot customers, you've got your initial flights going. Many people, especially in the industry, are familiar with beta. The next stage is about scale up. What do the next 12 to 24 months look like, especially now that you're in the public eye, Kyle? It's not a small private company in Vermont.
Yeah. We're still like, I still end up in a lot of places where people don't know who we are. I would say that, a tenth of the United States even knows that electric aviation exists, and a tenth of those people even know who Beta is, right? So it's a very small portion. So we're just barely getting started. Now, what are the biggest focal points in this next phase of growth? It is the furtherance of our industrialization. We made a handful of aircraft last year on our production line. We'd made prototypes before, and then we made aircraft on our production line. Doing the thing exposes the issues, the tolerancing, the production flow, the tooling strategies, the manufacturing engineering, the inspection points. All of those things are getting litigated and refined. And I'm looking out at the shop floor right now at engineers that are supposed to sit right next to every one of their installations. And they are deleting requirements, simplifying things, taking parts out so that the economics of the aircraft get better and better and better. We have to make an aircraft that's economical to buy and an aircraft that's economical to operate. I believe we've nailed the economic to operate. Now we have to nail the industrialization, the production flows. This also reaches back into, even though we're vertically integrated, we still have a supply chain to manage. And there are elements that, when we build the aircraft I'm looking at right now, the conforming aircraft, we have to be in really tight partnership with our suppliers to ensure that the pedigree and the documentation that proves to the FAA when we go out to get credit for testing that the thing we're flying is going to be consistently and repeatedly built over time. That's the effort right now. And we're doing it, at scale. We're not just doing it onesie twosies. I'm looking at 1, 2, 3, 4, 5, 6, 7, 8 aircraft in front of me, right? And those are going to move to the next index point. And we're building these things, and we've got this. The current administration has kicked the door open on the regulatory pathway to start deploying these.
No, I love that. Now, some of the companies we've heard about, Archer, for example, they've partnered with the likes of Stellantis when it comes to scaling up. Is that something you see down the road happening? You working with a large scale manufacturer in the production of these?
Yeah. Look, we have partnered with a number of folks at different levels on manufacturing. I think the most notable one and the one we're getting the most value of right now is GE. We have a great partnership with them. The things that they do that Stellantis and Toyota and others don't do is they certify propulsion systems, and they have production lines that are have production certificates, right? So where we get the most value is not necessarily in figuring out how to push the widget down the assembly line faster. It's how to do it in a way that is acceptable to the FAA. And conforming test rigs and data digestion. These are all very, very key to make a super reliable product for aviation. And GE has been an awesome partner on getting through some of those wickets. And I believe we've been a good partner to them as well. We brought some pretty spectacular technology to the products we've been developing together.
And hasn't GE Aerospace been one of your investors as well lately?
Yeah, so GE put about $300 million into us as a private company, and we have one major program, a turbo generator program with them, and we have other programs that are not public, and then they put additional money into the IPO. So they've been an investor in a technological partnership. I would tell you that the strategic partnership with them is worth way more than the investment to me.
No, absolutely. It's GE Aerospace is the blue chip name you want to have as a partner in aviation, especially as you're scaling up. Do you have plans for entering defense at all?
Yeah, I mean, we've had a large number of defense contracts. I think significantly more than anybody else in this space. We have talked less about it. I mean, I was told in our IPO that you guys do everything better than your competitors except for marketing. And here's another example. You're asking about defense. We have an amazing team that has worked to really create a product that is low cost, attritable, quiet, low thermal signature, and is right in the wheelhouse of what the Department of Defense needs, especially as we get into longer range, South Pacific and European theaters. And there's a lot of value in having small, low cost, attritable. When I say small, like 7,000-pound aircraft that cost, 1/20th of the existing large helicopters and can do very similar tasks and do it. By the way, one of the things that isn't recognized, and I think you'll be the first one that I'll say this to, is that a helicopter is physically limited in its speed and its range by retreating blade and by its inefficiency or its L over D predominantly. eVTOLs don't have that issue. We can fly faster and we can fly further. That's a tactical advantage for our military. And yes, in many cases, the fly further case requires hybridization, hence the GE partnership where we're creating a turbo generator. But it uses the physics of the eVTOL, the distributed propulsion, in order to achieve those technological advantages. And if I'm supporting our warfighter in China, in the South China Sea or whatever, in the Pacific, I don't want them to have an inferior technology or inferior product. So I think we absolutely have to, as an aerospace company, provide this to the military. And the military has been accepting it with open arms. I mean, I just got briefed with the many millions of dollars that we recognize in revenue just this past quarter in military programs. And when I look at our competitors, real fact sheets, they may have a lot of pretty pictures of this stuff. They aren't recognizing revenue, which means they aren't delivering valuable product. And that's what we're doing.
No, that's absolutely amazing. Since you mentioned marketing upfront, there was a recent comparison done on number of press releases per flight hour, and I think Beta was the lowest, and I believe Archer was way, way higher than you guys. So
Well, there,
I love
you
that
know,
you're walking the talk.
yeah, this is right. I mean, you have to do two things there. Like we have a rule internally. It's, no photo renderings, no CGIs. We never issue something about something that's going to happen. We only talk about things that have already been done, and we fly what we build. So that's a product of that. There was a subsequent Spears that came out about vertical flight, and they took ADS-B data for the vertical flights, and they were off by several orders of magnitude on our vertical flight campaigns, because when we do that, we're doing it in class Gulf airspace. Usually the transponder is the chase airplane, and we're flying over there. And the funny part about that is that it had showed some infinitesimally small amount of vertical flight hours on our airplane. And I had just walked away from a Saturday where I flew 12 flights, 2.3 hours. And I think the hours they were logging was like less than what I had flown that day. And I was like, oh, okay. Well, there's a lot of data that's missed. Am I going to go and correct that? Probably not. You know why? Because it's not how you start, it's how you finish. And I know what we're doing, and I'm confident in the progress that we're making. And there's going to be a lot of people that are going to try and call the race before it ends. But when we get to our first certifications and our second certifications and our third certifications, and people are like, okay, you guys started measuring who had the best shorts in the marathon. It doesn't matter who broke.
That's an interesting one. It's the first time I'm hearing that analogy.
Oh, I just made
Moving
it up.
from good, I love the originality here as well. Then, since you mentioned helicopters, I have to ask a blunt question: if these aircraft cost million, why doesn't the market just electrify helicopters via retrofits and be done with it?
Yeah, it's a good question, and we have actually electrified helicopters. So um,
Okay.
we understand that, and it's a great thought experiment. The lift over drag ratio of a helicopter, which is the ratio of like how far it glides to how far it sinks, is about 4. The lift over drag ratio of our airplanes, in the vertical, between 13 and 17, depending on the configuration of the aircraft. So you've got, a 4 times difference in lift over drag ratio. That means for every unit of energy that is either in the airplane or put into the airplane, you go 1/4 as far. Now, you're like, well, why is that? Why wouldn't you just change the lift over drag ratio? Well, the fundamental physics of a helicopter say it's never going to have a good lift over drag ratio. And why is that? Because you've optimized the helicopter for a different propulsion plant. A turbine loves running at the same speed all the time. And so you say, okay, well, if I'm going to gear reduce that and put it into a rotor head that turns at the same speed all the time. Why? Because it has a torque curve and has a torque speed curve. And you get off that speed, and all of a sudden you can't make the torque when you need it. So what do you do to make up for that? You put in a cyclic, you put in collectives, you put in things that allow you to keep things at the same speed and modulate the relative thrust side to side or collectively. Okay, we have a technical solution, therefore we no longer have a problem. However, if you take an electric motor and you put it in there, you get all the detriments of carrying batteries around. And now you have a motor that doesn't care what speed it runs at. It always puts out the same torque limit, right? And you're saying, so now I'm double solving the problem with collectives and cyclic for a motor that actually can vary its speed. So at least I can get rid of the collective, but I'm not using that function. I'm just running it at a singular speed. You're effectively leaving money on the table at that point. So now you have a suboptimal integration of propulsion with mechanics. And you end up with a helicopter that has pathetic range because its lift over drag ratio sucks. You're carrying all that complexity in the rotor head, and you have to carry batteries around. And my proposal is, and I said it before, if you're going to exploit the benefits, exploit the damn benefits, but respect the detriments. So electric enables distributed propulsion because you get rid of all that shit in a all that stuff in a helicopter, and you run in our case, a fixed pitch blade at a variable speed, because electric motors, you can commutate these things at whatever speed you want. And that's a flexibility that doesn't exist in helicopters. So that's like the technical reason. And I mean, at the very superficial level, is because it doesn't work very well.
Fair enough. One of the things I recall again in Toronto when I experienced the aircraft was this charger and a battery pack. You are investing in a charging network, in a charging framework, and a standard, as well as battery packs. How important is this in the entire equation?
Yeah. So the battery packs are huge because they drive the economic outcome of our business, and
Hmm.
in the sense that you sell an airplane for, say, 4 or 5 million bucks, maybe six, if you get a lot of features and pretty paint on it. But then over the course of the airplane, you sell $13+ million of batteries. And even while you're doing that, you grossly reduce the cost of operation for the customer. Therefore, you have to get really good at building and certifying batteries. So it's an important part of the business model. But the secret sauce within that is that every time you release a new battery, the performance goes up. That means, unlike any other aircraft in the world, the paradigm has flipped now, which is the worst performance you'll get on the airplane is on its first day. And by the time you retire that airplane, its performance will be significantly greater. So there's two reasons why that battery needs improvement and replacement. So that's a focal point of the business. And the chargers, just kind of landed in our lap where we wanted to do a lot of flying and nobody made a charger for high voltage, high rate, level 3 charging. So we went out and built it. Now, my experience in the past, we built a lot of different types of chargers. And it turned out that once we built it, we realized, geez, we can't put it into every airport unless we certify it. So we went and certified it. And then people started coming to us and said, we want to buy that. So we refined the product into a real good commercial product and started selling it to other people. And now we have a charging network that it goes all the way up and down the East Coast. It's going to go across the entire United States. We just put our foot down in a couple of places internationally. We won the Abu Dhabi Chargers. It's an elegant, beautiful, really, really high margin, great product for the business. And it serves a need to allow us, it's an enabler to put the aircraft out in the world. I think at the end of the day, the charging network may be as valuable as the aircraft because they're
Wow,
going
wow.
out fast, especially this year.
What about interoperability? I used to have a Tesla, and the Tesla couldn't use any other charger for supercharging other than the others. But then that changed, right?
Yeah.
Do you foresee that you'll be interoperable with other OEMs, including competitors?
100%. Yeah. We settled in as an industry on a standard through the General Aviation Manufacturers Association, which is a CCS based standard with a partition software element that allows for the right amount of data transfer. And it allows us to go to roughly 500 amps peak. Most of the chargers don't go there, and it allows us to go up to 1,000 volts. So it's a higher current rating than the NACS standard, which is what Tesla uses. The communication protocol is actually identical. So you can swap between the two with an adapter. Now, as you pointed out, sometimes that limits your current, but ultimately, like the little nozzle at the end, the little part that you plug into the plane is like $2,500, right? And if you want to change that, go change it, put an adapter on, whatever. The real value is the siting at the airport, the utility interconnection, the power electronics for conversion, all of the data transfer. That is already done, and that's all installed. So the standard that we have now is accepted by the industry. There's a bunch of companies that are on our standard. We're selling our chargers to other people. You can charge a car. You can charge a package delivery van. This is one of the things that we designed early. So UPS can charge their van and their airplane at the same place. Amazon could do the same thing. That is all very, very thoughtful, interoperable, and multimodal.
I have one more question, which I'm now thinking as we speak. What about leasing companies? Have you approached them? What has been the response like? Because leasing companies, at least for traditional aircraft, own most of them. Is that something? Is that something they're interested in?
Yeah, we actually have sales to existing leasing companies, LCI being one of them, and going later this month over to the lovely Ireland to meet with a bunch more because that's where they all seem to live. Um, Yes, is the answer. We're working with leasing companies. It's actually an even more interesting model than traditional airplanes because of the battery portion of this. And so that opens the door for a variable where, leasing companies provide capital, right? They provide capital and maybe an extension of your sales. Um, that capital allows people to break through the initiation and the integration of a new aircraft. Has to be thought about a little bit differently in electric, but they are an important part of this growth. I just read a book last weekend called Air Dogs. It was. Have you read that about Ryanair?
Yes, about Ryanair,
Yeah.
exactly.
Like the without the leasing companies, like none of that would have materialized. You know.
I hear you. Final few questions, Kyle. When I got in touch with your team, I think it was almost 2 years ago, initially to do this interview. I remember everyone email signature said team member. Your email signature says team member. You just hired someone who had a commercial. Everyone's called team member. You've firstly, why team member? Why is everyone a team member? And secondly, do you think you can preserve this culture going forward now that you're a listed company?
So you see this book I'm holding up. It's a
Yep.
short book that I wrote. It's called Team, and that's the extension on our website as well. The I want everybody here to know that this is their business and they're willing to do any job. And we give equity to every single employee here. And like frankly, I don't give a crap what your title is. If something needs doing, you better be willing to do it. And the only person that I've ever fired on the spot was somebody said, "It's not my job to fix that circuit board." And I said, "Excuse me, pack up your stuff and you're out." Like the team member is uh, I wouldn't say it's super important. I get that there's places where people are like, "Well, I need to know the hierarchy. I need to know who the decision makers are." I have people call me and they say, "Hey, I need to talk to somebody who can do X, Y, or Z in the company." And I say, "Hey, try me. Let's see if we can work this out together." And they're like, "Well, what's your title?" I'm like, "Hey, it doesn't really matter." And I know I'm being a little dogmatic about it, but the point is like, you know, a team member is different than an employee. An owner sees something that needs fixing or needs wrong, somebody who's really a part of it, and they just fricking do it. And if you're in a company where you have like these artificial and this remember this is a lot like the design of the airplane we talked about in our very first conversation, which is why not prematurely create ICDs in an airplane, because you undermine yourself of a thoughtful mechatronic design. Mechatronics, remember, is defined as a component or a piece that has multiple purposes in the same space and the same time. Where does the hub start? Where does the rotor end? I don't know. I can't see. They're the same thing. Where does the cooling start and where does the structure begin? I don't know. It's all the same thing. When you look around this company and you say, "Well, what do you do there, Kyle?" Well, today I'm going to do some engineering. And by the way, then I'm going to do some performance reviews. And then I'm going to pick up this right here and I'm going to respond to the FAA on the independent study for the future state of certification. So what am I? Like, what am I? And I don't mean to rant about the team member thing, but there's a job that needs doing. We have to stay coordinated, but to overly define those roles, I find it is just inefficient.
I love it. I love the passion. It comes through for sure. One more thing that I loved about the culture was I believe everyone in Beta who's a team member can learn to fly. Is that a perk you intend to keep going forward?
100%. Yeah. No, the everybody has the ability to do it. We don't force it on anybody. And pretty much, I can't think of anybody that hasn't at least gotten into being a student pilot. Not everybody is matriculating through to get their license, and that's their prerogative. But to expose themselves to the thing that we're doing, I think makes them a better engineer, makes them a better technician, makes them a better service. But also, it drives a passion and it provides a connection to the mission that we're trying to accomplish. So, yeah, I've had lawyer after lawyer tell me that that's got to stop when you pick a thing, take out external investment, go public, whatever. And nobody has shown me that actually is the case. So we're going to continue it.
I love it. Well, I hope you keep the small company spirit and the passion alive as you grow bigger and have an impact around the world. The final part of this interview, Kyle, is called the rapid fire round, in which we get to know you a little bit more personally, and you got to give me very, very, very short one word or short phrase answers. So simple things like, what's your favorite aircraft?
The Helio Courier.
Ooh, nice. Your favorite airline?
Favorite airline. I have an affinity. I shouldn't say this, but I have an affinity for Alaska Airlines because I had this
You
the
do.
most pleasant experience with a stewardess who solved a really hard problem for me going to LA, and like those little things matter.
Love it, love it. Have you signed up for the new Atmos card? I heard it's really good.
No.
They have a new Visa card that they've come up with for their new loyalty program. Since you like Alaska, favorite airport?
Uh, I got to say Burlington. I mean, it
Yeah,
has so many memories.
small, in and out. I love it. Favorite city?
Um, yeah, aside from my own home city, um, I I like Washington D.C.
Wow, that's a first on this podcast, I have to admit.
Yeah,
So
I
for
mean,
someone
look,
who likes it.
it doesn't have the best nightlife. It's certainly whatever, but there's I mean, I just have such great memories of walking through every one of those Smithsonian museums.
Oh yes, that is absolutely correct. What do you do in your free time, Pat?
I think about airplanes, fly airplanes. When I get, my wife loves it because when she really pisses me off, I go and I build stone walls or furniture. And, and like, if it's a Saturday and she wants me to do something that I don't want to do, like finish a garden, she'll just say something that really ticks me off. And I just go and build stuff. I'm
Wow, love it, love it. Do you have a favorite movie or a favorite book?
um, I think my favorite book just changed. I mentioned Air Dogs, but right before that, I wrote a book called Herman the German, which is about about Newman, Gerard Newman, who is a engineer who fought with the U.S. From Germany and then ended up running the GE's jet engine division.
Oh wow,
And it's an autobiography, and there's a whole bunch of typos in it because it's not in publication anymore. But it's a fabulous book, and it's hard to get. Favorite movie?
interesting.
I'd have to say is still Point Break. I love the quote: "Fear causes hesitation. Hesitation will make your worst fears come true," and it's how I operate in life. And it's just been
I think I think when we meet for the first time, we got to do some book exchanges. I want to get this copy that you just mentioned, and I hope to pass you a couple of copies of my book as well, which hopefully will be refreshing reads on aviation.
Let's do it.
And final thing, what is something you'd like to learn?
Um, I've been pretty obsessed with the system of systems engineering recently. I just kind of finished one of the MIT Open Courseware trying to figure this out. I think that there's a big breakthrough to happen as we get better at systems engineering, and we don't try to distill it down to a black and white thing, but we start to merge elements together, and a lot of optimization can happen. And I think that our new AI tools will help us do that. So I've been focused on learning that, but ask me in 2 weeks, it'll be something different.
Okay. Sounds good. Always learning. And final question. What's the best advice you've received?
It hurts the same if you sit there and cry about it versus if you get up and keep playing.
Lovely. I love it. On that note, keep playing, keep flying. This was a fantastic conversation, Kyle. Thank you so much. Thank you for listening to this episode of Sustainability in the Air. Aviation is one of the hardest to decarbonize industries, yet there are multiple paths to get to net zero. Awareness is key to a green future. So please give us your support to help our sustainable aviation insights reach a wider audience. You can do this by sharing this episode on your network, on LinkedIn, Twitter, or even WhatsApp. Or perhaps you might consider leaving a review on Apple Podcasts, Spotify, or wherever you listen to this episode. You can start a conversation with us by writing to us at podcast@simpliflying, that's simply with an i.com. And for more content on sustainable aviation, please visit our website green.simplifying.com and join the movement. Sustainability in the Air is an original podcast by Simplifying. The show is produced by Juraj Toth in Slovakia. Dirk Singer is our Director of Sustainability, who leads research for each interviewee out of Greenwich, UK. Shubhadeep Pal is our Supervising Editor based out of Mumbai and Singapore. The articles are written by Ayushi Badola in Dehradun in India and Meera Hull in Montreal, Quebec. Creative design is led by Ligia Esteve in Montreal. Baiba Drimen is the project director for the show based out of Valencia, Spain. Special thanks to Wendy Sim in Singapore. And I'm Shashank Nigam, the CEO of Simplifying and your host. Please feel free to connect with me on LinkedIn.